Alright, I'm going to explain this method called chunking factoring, and then I'll also show you that it actually works even if you don't understand the chunking. Okay? So chunking works when you focus on the A and the B. Class, what two letters do you focus on? The A and the B. What you're trying to do there is find the greatest common factor for these two. What's the greatest common factor? 9? 3x. Okay, watch this. 3x is my greatest common factor. If I do this expression squared times 7 times that expression plus the 10, because 3x squared is 3x times 3x, which gives you 9x squared. And 7 times 3x gives you the 21x, and there's the 10. Okay, so what do you do here? In higher level math, when things get complicated, you can do a substitution. Everyone say substitution. Instead of writing 3x, I'm going to write, I don't know, any variable you want. You can pick z. So every time I see 3x, I'm going to write z. Z squared plus 7 times z plus 10. And essentially what you have here now is you just have like a quadratic equation now that you can factor. Class, A times C? Pretend the parentheses aren't there. That would just be 10, right? A value is 1, C value is 10. What's your B value? 7. So again, if you're getting confused with the variable Z, just think it's an X. Two numbers that multiply to be 10, but add to be 7. 5 and 2. So I would write the 5 and the 2. So now I have z plus 5 and z plus 2. But we did something, didn't we? Class, what did the z equal? 3x, right? So every time I see z, now I'm going to write what? 3x. So now I have 3x plus 5 and 3x plus 2 is my answer. So let's review the chunking method. The chunking method for factoring only works when you have which two letters? A and B have what? Have a greatest common factor. Okay, here's the good news. Xbox method is so wonderful, you don't even need to use this chunking method. But if you use this method,
who's that dummy? Don't text me, it's not fair. Huh?
So the Xbox method says even though you may not recognize this chunking method, you can still do the problem. Let's do that together. Class, why do I have to use the box on this side but not on this side? Talk to your partner, 5 seconds. See if you get it. Alberto, why did I use the box on the right side but not the left? Because I just felt like it. There is a concrete reason why. I'm going to call back on you. Jeremiah, why did I put the box on the right side and not the left side?
To be honest, I wasn't paying attention.
Joe?
Is it because there's a number in front of it?
There's a number in front. Okay. So when there's a number in front, when the A value is greater than 1, you must use the box. Jeremiah, when do you use the box?
When it's greater than 1.
When the A value is greater than 1. Alberto, when do you use the box?
When the A value is greater than 1.
Notice on this one, my A value is actually, with the substitution, my A value is just 1. That's why I only used the X. Class, what's A times C? 90. Class, what's my B value?
21.
Okay. I need to think of two numbers that multiply to be 90 but add to be 21. Now, if you get stuck like I am, you can just list out all the factors of 90. 90 times 1, 30 times 3, 45 and 2,
15 and 6.
Any others? And you guys said what number?
15 and 6.
Let's use it. Okay, some students have had some struggles filling this in now. With your partner, take 10 seconds. I want you to fill in the box now. Ready, set, go.
Can I erase my name?
Alonzo, what do I write here? On the top here? Nine x squared. Alonzo, what do you put in the bottom left?
Like 6 different videos like that.
15x. What do you put in the top right? Always? 6x. He added the variable x because you're splitting the terms here. And Alonzo, what goes there? The last term, 10. Alex. Greatest common factor? Class, what's the greatest common factor? 3x. How about this direction? 3x. Greatest common factor? Greatest common factor? 3x plus 5. 3x plus 2. Look. Same answer, right?